Welcome to Next Gen Manufacturing. This is where we get into the really tiny details that are making a massive difference in how things get made. And today, we're tackling a fascinating paradox. How can a measurement that's way, way smaller than a human hair create one of the strongest forces you can imagine? So let's just start with this puzzle, because it really gets to the heart of what high-performance manufacturing is all about. We are talking about a level of precision, of accuracy, that's measured in 10,000ths of an inch. I mean, that's almost nothing. So how can something so incredibly small end up creating one of the most powerful, most reliable connections we have in the world of machining? It just seems impossible, right? But believe me, this microscopic level of precision is the secret ingredient. So, how on earth does it work? Well, let's dive in and break it down. Okay, so in the world of high-speed, high-precision manufacturing, that connection between a cutting tool and the machine holding it, well, it's everything. Just picture a tool spinning at tens of thousands of RPMs. If there's even the slightest wobble, the tiniest bit of imbalance, you're not just looking at a sloppy cut. You're looking at a catastrophic failure. So getting that connection absolutely rigid, totally perfect, it's completely non-negotiable. To really understand how we get that perfect, unshakable fit, we kind of have to learn the language that machinists use to talk about it. And that language is all about tolerances. It's basically a hidden set of rules that defines what's acceptable for a physical part, how big or small it's allowed to be. So when you're trying to fit one thing into another, there are really two fundamental ways to think about it. You can start with a hole and then make sure the shaft fits inside it. That's called the hole basis system. Or you can start with the shaft, or as we call it, the shank, and design the hole around it. And that one, the shank basis system, is the key to everything we're going to talk about today. And that brings us to this really crucial little detail, the lowercase letter h. When you see an H tolerance in machining, it's a promise. It's a guarantee. It means the shank of that cutting tool has what we call an exclusively negative tolerance. It can be exactly the size it's supposed to be, or a tiny bit smaller, but it can absolutely positively never be even a fraction larger, and that is a critical piece of the puzzle. Now, the little number you see after the H, that tells you just how precise we're talking. It's called the International Tolerance Grade, or IT grade. The lower the number, the tighter the tolerance. So for a really small shank, an H6 tolerance means it can't be any bigger than its target size, and it can't be more than 2/10,000ths of an inch smaller. I mean, that is just an astoundingly precise window. All right, so we've got the lingo down. Now, let's see how all this knowledge about tolerance unlocks a totally revolutionary way to hold a tool. It's called a shrink fit, and it uses a really basic principle of physics to create what is pretty much a perfect bond. Okay, so here's the foundation of the entire system, and you gotta get this. By design, the hole in the tool holder is actually smaller than the shank of the tool itself. So at room temperature, you just can't push it in. It's an impossible fit. That is, until you introduce a whole lot of heat. The process itself is actually beautifully simple. First, you take the tool holder and you stick it in an induction heater. This heats it up really fast and evenly, and the metal expands, making the hole just big enough. Step 2, you slide the tool shank right into that expanded holder. And then step 3, you just let it cool. As that holder cools down and contracts, it shrinks, clamping onto that tool shank with this incredible 360-degree force. And right here, this is where it all comes together. This is the light bulb moment. Why is that H6 tolerance we talked about the absolute perfect partner for this shrink-fit technology? Well, it's because it creates the ideal conditions for this whole thermal process to work perfectly every single time. This combination of H6 precision and shrink-fit gives you 3 huge advantages. The gripping power is just immense, and it's perfectly uniform all the way around the tool, so there's zero chance of it slipping. The runout, which is really just a fancy word for wobble, is practically non-existent, which means you get incredibly clean, accurate cuts. And because that fit is so perfect, the whole assembly is perfectly balanced, which is absolutely critical when you're machining at insane speeds. This tiny number, this is why it all matters. Because that shank can only be at most 2/10,000ths of an inch undersized, you get a predictable, perfect interference fit when the holder cools down. That guaranteed precision completely eliminates wobble. And what does that mean? It means your cutting tools last way longer, and the parts they make have a much, much higher quality surface finish. It's a tiny detail with a huge impact. So you see, at the end of the day, mastering these almost invisible microscopic details is what allows us to make these giant leaps forward in manufacturing. Pushing for these tighter and tighter tolerances isn't just about being precise for the sake of it. It's what unlocks higher speeds, better accuracy, and way more efficiency across the board. You know, this whole idea really gets to the heart of it all with this simple statement. A secure holder connection is vital to the performance of the tool in your application. Everything we've talked about, the tolerances, the heating, the cooling, it all comes down to creating that one perfect, secure connection. It is the absolute foundation of high-performance manufacturing. So we'll end with this question for you to think about. We've seen how a few 10,000ths of an inch can completely revolutionize how we hold a cutting tool. As manufacturing keeps getting faster and smarter, what's the next microscopic detail that's going to lead to another giant leap? It's by understanding and mastering these tiny, almost invisible details that the next generation of manufacturing is going to be built. Thanks for joining us on Next in Manufacturing.